Before we begin section 6.1 day 2, I just want to give you guys a little bit of advice about the whole chapter. First of all, don't panic after the first day of the chapter. Doing the trig identities is quite a jump into theoretical math, and it does take a little bit of time before you start to gain a little bit of comfort in it. So today hopefully helps you guys feel a bit better about it. Now, the next one would be about the identities themselves. I'd asked you guys to go to page 296 in the textbook, and there you saw the first 8 of the identities. These guys can be called the fundamental 8. Now, first of all, I stand by this. You're really going to help yourself out understanding chapter 6 and being able to see the problems when you've memorized these fundamental 8 identities. So I'm going to challenge you guys to take a moment, commit them to memory. It doesn't take very long because probably you know 5 or 6 of them already off by heart after just one day. Now, the second one would be, right, where to write them down. If we were face-to-face, what I would actually have is a nice typed version of the unit circle as always, but then I would also have typed the identities here. And it's not just the fundamental 8, there are more identities to come in future chapters. And so what I'm going to probably recommend you guys do is start by writing down the fundamental 8 identities and don't spread it out too much, okay? Get it in a spot here, maybe about a third of the space, because we'll have more things that we have to write down, more identities. And then this sheet should always be out anytime you're working in chapter 6. It's going to be your reference sheet. Now, with that said, again, I would probably have your textbook open to page 296, or you could even pause the video, write the fundamental 8 down in your unit circle, and then just have that up. Now, what we are going to look at today is a second day of simplifying trig identities. So what simplifying means is to take whatever is given and make it as small as you can. Now, there's some textbooks that will have it where it doesn't always suck down to one thing. That's fine. I am only ever going to do questions or give you questions that only go down to a single term or a single number. Now, our first one is almost too easy. It doesn't really let you sink your teeth into it. You get the idea, but sometimes you need something a little bit bigger to fully understand it. So this is going to be the name of the game. We look at this and we have to do something. We have to somehow manipulate it without breaking rules of math. That's where the identities come in. And you'll get really used to this. We will write this down in a future date. When you look at something and you're like wondering what to do, if ever you're kind of stuck, your backup plan should always be to look at it and turn everything into its version of sine and cosine. So cotangent, yes, I know it is 1 over tangent, but it is also cosine over sine. And then if this is already sine, just leave it alone. And if you want to, you can write it over 1. Then usually something appears. In this case, the final answer, because the sines cancel out and you're left with just cosine x over 1. So that single term, that is the simplified version. And we have not broken any rules of math because we're using the trig identities that have been proven to be true. Now, in your second example, this one right here, I'm really going to try to enforce upon you guys, memorize your first 8 identities. Even though you always have them in front of you, even if you were doing a normal exam for me, you'd always have them given to you, but you'll never truly be good at chapter 6 until you've memorized those first fundamental 8 identities that you were introduced to yesterday. And here's kind of the idea. You look at this and you're thinking, okay, how do I suck it down to one term? Well, here's what it is. Cosine squared plus sine squared is equal to 1. That right here is an identity. It's replaceable by 1. If you don't have the identities memorized, that might not have come into your head. You might have had to have waited for a teacher to give you the advice. And then on that same respect, 1 plus tan squared. If you don't have the identities memorized, you don't even have them in front of you, you might be wondering, well, now what am I going to do? But once you have the identities memorized, it should be like, wait a minute, if I look at the Pythagorean identities, 1 plus tan squared is equal to secant squared it's replaceable by. And we have taken this fairly large term expression and sucked it down to just a single thing. And we don't worry that the square is there. Now, for your next example, this is where you have to use the instincts that are there. For number 3, it goes 1 minus sine theta. It doesn't matter whether it's a theta or an x. You just have to include the angle symbol. Always include that. And here is what should be going through your mind. You should be thinking, I wonder if I FOIL. And your instincts are true. If we FOIL this out, first times first, well, it's a 1. The outer is plus sine x. The inner is minus sine x. they cancel out. And I had written it all out in the PDF version of the notes. And then last times last is a minus sine squared. So that had to have been something productive. And then once you've memorized the fundamental 8 identities, 1 minus sine squared, you should be like, wait a minute, I know that one. And this is not written down in the PDF notes. We wrote this down yesterday. The identity cosine squared x plus sine squared x equals 1, if we just manipulate it. If I take the sine squared and slap it over, 1 minus sine squared is equal to cosine squared. It's replaceable by cosine squared. And now we've taken it to a single term. That's as small as it can possibly go. For our fourth example, this is really where you start to dig in. This is where it gets a little bit bigger, a few more steps than what we've already done, but sometimes this is very important. Sometimes you need to see multi-steps to really get a taste, a feel for what's actually going on, what you're being asked to do. And so don't panic. You are not supposed to look at this and say, I know exactly what each of the steps are, because you've never done a question that has some of these steps. And again, second time today, in a future lesson, we will write down what are some of the things that you're supposed to spot to do these questions. Right now, we're just trying to experience them, and then we'll put it in handwriting, the different options that you have to be able to simplify it or later on prove it. So for this first guy, we look at the question. You should not be thinking the Pythagorean identities. There's no ones, there's no squares. So here is going to be, again, what your backup plan is that we write down later on. If you look at something and you don't quite know what to do, if something is not sine or cosine, well, turn it into it. So tangent is sine over cosine. Leave that alone. Leave this alone. Don't do anything. And then what you're hoping for is that something pops out. Okay, that then a next step might be available. In the previous questions, it was your final step. In this one, it's just, what can we do next? So I just simply multiplied this out. Sine times sine is sine squared, and then a cosine times 1. Now we're looking at this and then saying, okay, now what do we do? Here's your hint. We are adding two fractions. You have to be asking yourself, well, how, all the way back in elementary school, do you add two fractions? You get a common denominator. If you look at this, you've never done a common denominator with trig before, but you just follow your rules. The common denominator is cosine. So what you could actually do is you could times this fraction, top and bottom, by cosine theta. Sorry, that's so messy. And then what you would have is a common denominator. You would have cosine squared over the denominator of cosine. And then you would have sine squared. And this one didn't need to be multiplied by anything because it already had the common denominator. And then this is what you can actually do. You can write it like this, or it's okay. You can just jump right to writing the whole numerator over the super common denominator. It's the same thing. You're not breaking any rules of math again. Now here's where, again, once you've memorized the identities, we're only two easy steps away from a finish. Number 1, cosine squared plus sine squared, that should be jumping off the page and saying, hey, I'm something good. It is a value of 1. That's one of the Pythagorean identities. Now, 1 over cosine is almost done. It's an identity itself. It is equal to secant of theta. And now we've taken something fairly large, multi-step. We've used multi-strategies. We've changed everything to sine and cosine. We did a common denominator. We used Pythagoras, and we used a reciprocal identity. Now you can really start to sink your teeth into the questions. Now, our final one is one where you might look at it and it might appear impossible, way too big. It's time to tap out. But if you just stick to your guns, it's not bad. I'm going to just take a moment and tell you guys, you have to trust your instincts. If you glance really quickly at number 3 in the PDF notes, if your instinct, even before I began, was to do a FOIL, well, it served us well, and we got to the answer fairly quickly. Now that we are done, number 4, when you look at this, this is your key, there's an addition, and how are you going to add these two fractions together? Well, you got to do a common denominator. And even though you might be thinking, no, that's too big, or I don't want to do it, it's going to be our technique. Because if you look at it, based on the little bit we know, what else are you going to do? So it starts off with, we have our first fraction. I'm going to just space it out a little bit so I have room to do the common denominator. We have our second fraction. And if you look at the common denominator, you got to go back to the old days. If you had something like 2 over 7 added to 3 over 5, well, you times this fraction by 5 top and bottom, this one by 7 top and bottom. You're not changing anything. The rules of math stay exactly the same. So we're going to times top and bottom here by secant x minus tangent x. And again, it's a bit of a pain to write down. You got to do top and bottom. Sorry about the messiness. This one. We're going to times top and bottom then by secant x minus tangent x. Now, in your very next step, here's where then things start to get better. First of all, let's do the denominator. I know it seems a little bit out of order, but it'll just clean things up much bigger. The common denominator is this. That's the super common denominator. And what I'm going to do immediately is FOIL it out. When I FOIL this common denominator out, and I think I missed a plus sign right here. I'm very sorry, you guys. When I FOIL this out, this is a conjugate. First times first is secant squared. The outer and inner will cancel out because it's the exact same terms, opposite signs. And then last times last is a minus tangent squared. Now we just hold tight for a moment. If we look at the top, there's no multiplying. There is just a series of additions. So you have a secant plus another secant. You actually have 2 secant x's, and a plus tan and a minus tan cancel out. So we're getting close. Now, the finish is kind of a neat one where you might be like, oh, wow, I didn't see that coming. It's right here. And I'm going to just do another color change. I'm going to go back to black to show the end of our day. The secant squared minus tangent squared. You might be like, well, what the heck are we going to do? I repeat a third time. Once you've memorized the fundamental 8 identities, you will start to see this. This will be eventually jumping off the page, not before you've memorized, but after. And this is an identity. In our identities, we have 1 plus tangent squared is equal to secant squared. And then if you take this tangent squared and slap it over, secant squared minus tangent squared is equal to 1. This is equal to 1. We are done. We have taken this down to a single identity. And again, only experience will help you get this. So memorizing the identities, doing all the practice problems, and then these puzzles become very, very beatable.